Hi everyone, my name is Mukund. I'm a software engineer at Twitch. Can everyone hear me and stuff? Yeah, I guess. Okay, cool. Let me know if there's anything wrong in the middle of the talk. Cool. So thanks for coming. I've been to a bunch of Ember meetups, mostly in New York, not here. And the New York meetups are, well, I don't know, maybe it's just our space, but like this is quite big, so I'm so glad everyone made it. Like, thanks for coming. Yeah. Cool. So this is actually not about my work at Twitch. This is about a personal project that I've been working on, which is a music player. It's called Suzanne. So this is Suzanne. It's kind of a Foobar clone. Foobar 2000 is another music player. It's really fast. It's unfortunately Windows only, so I run OS X, so I can't use it. And so I built. This is really a Mac version. I used Wine for a long time. This is actually a web version, so that way I don't have to keep my music on my computer. So anyway, I'm not going to spend too much time on this, but it's basically a music player. It's named Suzanne because it's named after a Norwegian artist called Suzanne Sundfør, who was my favorite artist the week that I started the project. And if you search for Suzanne, it's actually with an S. So I'm not even the best fan, but it's okay. Yeah, but it's still, she's great. Okay. Oh, right, there's a demo. Let's see how this works. I have it running locally. This is famous last words. I don't have things mirrored, so it's kind of awkward. So yeah, this is really clumsy to work through, so I'm probably actually just going to search these GIFs that I have. But the app works. It's a demo. I mean, I can let me. I can click on things, and you can get like album titles, and then I can search for stuff, and it'll show. Yeah, the slides are actually better. So. I want to focus on a couple of things here. First of all, like when it first loads, wrong slide. When it first loads, there's like a big lag. It'll look jumpy at first, and I actually, as soon as it starts, I click and I start typing a search here, and you can see that the UI doesn't respond, right? So that's like the first clue that something's off, that's not really responsive. If you're building an app, your users want to be able to start using it immediately. And then the second thing really that is that when you start searching, the same thing happens. So, this is some familiar stuff to folks who have used the Chrome debugger to debug performance. This happens because you're taking too long to do a frame, and so the CPU is computing things where it should be reacting to your events, and that takes too long, and so it seems jumpy. And if you search for jank busters, you'll find a whole bunch of great talks by folks who are much smarter than me on how to debug this. But one thing you can do to fix UI stuff is, well, before I get to that, let me just give an overview of the app to figure out why this is happening, really with an understanding of the software. So the thing you should know about Suzanne, it's basically a JSON file. Like the whole app is basically a JSON file with like a bunch of tracks and albums. I tried to keep it simple in that way. It's like all the clever stuff is done using web APIs, right? I don't want to build anything like a player on by myself. So you get a big JSON file, and then it gets sent to two services. The metadata service, which just stores a bunch of tracks indexed by the ID, and the search service, which will like form these strings so that you can search by them. Immediately, you can start to see some issues with this. For example, I'm doing a bunch of JSON parsing. Like I could reformat the JSON so it actually like works for the search service, so I don't have to like mess around with it a bunch, right? Like, so there's like optimizations here. But the overarching goal of this talk and like the big like thing I really wanted to play with here is web workers. And what web workers really let you do is they let you move stuff, move a lot of this complex processing, right? I'm processing a large JSON file. I'm trying to construct this like, is this going to have 20,000, 50,000 rows on the fly? And that's the first thing I do when the app hits. So obviously it's going to slow down. Wouldn't it be nice if I could push that off to a separate thread and then the layout works, right? So that's the pitch of web workers, and this hopefully shouldn't be new. Well, maybe it is. I'll go over this. So the web workers API, this is MDN's definition, but it basically gives you threads, right? And the web workers has been around since 2009. So it was first, conceived, the drafts were in 2009. And to give you an idea, that's when WebSockets was also the first draft happened around 2009. At least in my mind, right, WebSockets, I use them a bunch at work. I've used them on many of jobs that I've had, but a lot easier in my mind to integrate than than web workers. I'm mixing up all the APIs. Runspired, or Chris Thoburn, who's Runspired on Slack, said in some talk that he thinks that the idea is that API friction, right, is the reason that folks don't build on top of this, because the APIs are so low level that you have to build a lot of stuff before it gets useful. And it's based on the Extensible Web Manifesto. This is intentional. But that means that we have to build a bunch of stuff to get this working. And what I'm hoping is that I can show you a way to do this quickly, right? Here's the API just generally. I'm going to kind of breeze through this. You give the name of a script, a JavaScript file that is available. Sorry about that. And then you create a worker, and that will spin up another thread in Chrome or whatever your browser is. And the thing to note about the worker is it's in its own scope, and it's got a limited set of functions available. And these limited set are pretty powerful, but the obvious omissions are things like DOM, right? And the one other thing is you can call, there's some nice APIs here. The import script API is for web workers, and it lets you basically insert a script tag, right? It functions like a script tag. It'll run a JS file, and then if you have globals, you can access them, right? And you can use IndexedDB, which I do in my thing, because it's a bunch of information that should be in a database. The parent-to-child communication is done using post-message and on-message. This should be familiar if you worked with iframes, or different tabs and stuff. So. Message channel allows you to create, so on message and post message is you can think of this as two scopes they want to talk to, or two scopes. It can be an iframe, it can be the parent window, it can be a worker in this case. They want to talk to each other, and they have these two functions to communicate back and forth. The problem is, if you have a whole bunch of logic going on, you want to, it can be noisy for everything to go through the same channel. So they give you the message channel API to construct new channels. And then there are shared workers, which is out of the scope of this talk, but basically if you ever want a worker that works with multiple scopes, multiple iframes, from an iframe to a window, that kind of stuff, you can use a shared worker. Those are too complex for me to really dive into in further detail here, but so that's kind of the overview. I'm going to focus mostly on how are you going to use this in Ember. That's really and specifically in Suzanne, how I used it. And hopefully, and I'm going to show you a sort of a generalized way that you can conveniently use it quickly, right? So this is the old code. So if you remember the old overview, it's there's a metadata service. It fetches some JSON, it fetches some tracks, and now you have tracks that are available. And this is how it was before. And as soon as you spin up the app, it's going to call fetch JSON, and everything freezes up. That's the problem, right? The suggested refactor is that you create a metadata API service, and you move most of your logic to the worker. So if you look at the really hard stuff that's happening, right? Fetch JSON, any kind of mangling the JSON to make it look like how the search service expects it, right? That happens in the worker file. And so that heavy-duty processing, you've moved it to another thread. That's the real power of this. And that'll talk back to the metadata API service, which exposes these functions to the rest of your app. That's the overarching goal. Give me a second. I'm gonna. So the advantage of this approach is you're moving most of the logic into the worker. Now, this introduces a problem because how are you, metadata API service and worker have to communicate and they don't have, for example, promises out of the box. You only have this post message and on message API. So let's look at, for example, how you would call fetch tracks. The metadata API service would call fetch tracks. Now the worker, the API service which owns the worker would call post message and it would say, give me the tracks. Now the worker will do all the heavy lifting for you. And it'll return immediately. The metadata API service will return immediately a promise telling whoever's calling this, say your application route, I'm gonna get this, hold on. Then the worker is gonna work, you're still waiting for data to come back, and it'll post message back the tracks, and then metadata API can resolve it, right? So you're talking through post message and on message. One other thing to note is that when you're passing message from the worker to the metadata API service, when you're passing data from any worker to using post message, it will make it uses the structured clone algorithm, so it'll make a copy of the data, and this can bite you if you are, if you're transferring hundreds of megabytes or some, large amount. Mm-hmm. Yeah. Yeah. So the question is, how is this different from using something like fetch, where you in the parent app? Is that right? Yeah. So the advantage of using this moving this to the worker is, you're right in that it's still going to say, if you remember the app, it's still going to say loading, right, as it's loading. The advantage is now when the user is typing stuff as it's loading, the output's going to be there, right? The layout, the view layer, whatever's rendering, the renderer is going to be able to respond. I don't know all the full Chrome stack, but it'll be able to respond to your events because it's not frozen on this computation. The computation's in the worker. Does that answer your question? The thing is, if you're using promises, whatever the function you're calling to promise is going to be called in the same thread. And so you need this lower level API to be able to push it to another thread, because you have, I don't think you have the kinds of tools to say, no, this is more important than layout, this is less important than layout. And even if you did using something like request animation train, that's going to be really hard to time that correctly. Does that make sense? It's putting all the work on you to kind of break this up and say, we're getting events, now let's freeze up. Anyway, thanks for the question. Yeah, we can go over this afterwards. That's an important question. So the problem here, this works fine for a single worker and a single service. The problem is, what if you have, say, multiple functions, or if you have multiple services? If you have multiple functions that are talking back and forth to a single worker, now you get a bunch of responses back, and the service doesn't know what's what, right? Who to respond with. This is not, these symbols here are supposed to be promises, and it clearly didn't work. But there are 4 promises, you don't know which maps to which result. So how do you solve this? Luckily, this isn't something that I have to come up with on my own. The simple, straightforward solution is really to add an ID to these invocations. And this is a technique that's I didn't make this up. I think Robert was saying Phoenix, the Erlang framework, has channels, and that's a very similar philosophy, that where you have a single channel to talk through, and you need to have multiple invocations, you need to make sense of them. So when you tag this, now you're including this invocation 1 tag to the worker, and the worker transparently passes it back to you. And now you know which promise it is, right? and here it's not all that impressive, but now you've got 4 calls, and you can map each square box or box, aka promise, to the result correctly. So that's the advantage. And I've thrown this into a repo, which you should check out after the talk. I'm going to make it public. My bad. But let me just give you a quick example of how you can do this using the library. So it'll save you a bunch of code, basically, right? Because the whole point of this is so you don't have to write all this like ID passing cruft. This is how Suzanne implements this using the add-on that I just showed you. You import. This is specifically the service part. So this is the API that the rest of your application talks to. And you define, for example, a fetch JSON method. And all that's doing here is calling post message with basically the same parameters, right? Here I just construct the URL, but and you can treat that as basically a function call that returns a promise. And that simplifies things on your end. Now, the other thing is, there are a couple other things to note. You have to import web worker from the add-on because the service implements, the post message function, for example. And you have to give a worker name, which is the name of the file where you store the worker. That's how it knows which script to load. And on the other side, the worker will implement. This is the worker. So when it starts up, it creates a database using IndexedDB, and then you can import scripts there, so you'll have the libraries available to you. And then, this will instantiate it, and this will implement fetch JSON. And all it's doing here, there's a typo in this. It's supposed to return a promise. There's no return in that invocation, but it returns a promise, and that's proxied to the parent app. The ID stuff is done for you, and you can create multiple services like this, multiple workers. That saves you from having to basically invent this yourself in your application, right? I think this is like a good balance between kind of writing everything correctly immediately. There are great projects that are working on this. Ember Skyrocket, Runspired is working on, has a more ambitious API than this, and it's going to be more work, and I think long-term that's the right solution, but this lets you get up and running, in a matter of days rather than weeks. Thank you. That's basically the talk. Let me actually demo. I think that's good. I was gonna demo the final piece. Let me see. I can demo the main application to show you like how it is when it's all done. So I've improved the UI as well. And then you can search for, Beatles. There's a little bit of delay, but it's pretty fast. And I've been using it for a couple of months, so it works. Can you remove the? Oh yes, good question. This is not cache, but let me just close. Let me just close this and completely open it in a new tab. So, I'll have to set it up to test, but ideally, this is another note. When you're talking about performance stuff, really the right thing to do, it's kind of an admission on my part, is to run Chrome debugger and make sure you test all these things so that you have a good comparison. Your question is, the add-on doesn't work with Ember Data? Web Workers doesn't work with Ember Data? Good point. I'm not using any Ember stuff, so this is how I get around this. So the worker itself is a completely empty context. I've imported Dexy, but otherwise I'm just handling the JSON, right? If you need to do a lot of store-related stuff, you're gonna have to build more stuff. That's it. Yeah, definitely. Really, the big one is the the most immediate thing is that when you're loading, you can immediately start typing, and there's no delay. You didn't see this before because it's loading from localhost, but it would take about 5 seconds to start up because it's going to have to download this 5 megabyte JSON file. Now you skip that because everything's in the database, for example. The other thing is the search itself is actually a lot faster just because the search is indexed and performed inside the worker thread. And so as you are typing, little, I don't know, like I can actually see these results getting populated with each letter. Whereas before, if I go back to the early slides, you'll see a clump of 3 letters and then results, and then 3 letters and then results. That means that the computation, the layout is blocking on the computation being done. So that's the biggest wins. Yeah. Great. Yeah. I'll move on to the actual slide, which you all saw. But if I have it. Twitch is hiring. Can I present? Well, this is anticlimactic, but I need to work on the tempo, right? So Twitch is hiring. We're a small team. We're doing a lot of great work. I think Chris, our engineering director, is going to be talking more about this a little bit later. But yeah, please apply. We have Robert Jackson, who's also going to be giving a QA after Nathan's talk, and who is as friendly and as smart as his reputation. So please join us.